Hi again. So today I'm going to explain some set notation that we'll use for our functions, and also these brackets here, which actually, if you know your inequalities, will make really easy. But yeah, we're just going to go through these. So by the end of this video, you should know what all of these signs and symbols mean and how that you can express them. So the first one's really simple. It's just this R minus and R plus. Now if you do specialist maths in Australia, or you do further maths, you'll actually know what this is here, or you'll be building to this, which is these are real numbers. Because we also have these things called imaginary numbers in those topics. Just to understand, an imaginary number is any number that is the square root of -1, which you can't do in our real number system, so that's why we have imaginary numbers. So a real number is any of the numbers you've been dealing with all of your high school life so far. So any decimals, any integers, and the only difference between the two is that on this side you have real positive numbers, okay, expressed by the positive, and you have real negative numbers expressed by the negative. That's really it. It's quite simple, but very useful when you're expressing, and I'll show you as we go through the next couple of things, because it really matters when we're expressing real numbers, because we can say it means all real numbers, or in this case, real positive and real negative. Okay, so that's our first set of pieces of notation. Very simple. Now these ones here, okay, this is a way in order to express that something exists in the set. So let's just say that we've got a dice roll. So let's say I roll a set of dice. You can get a 1, 2, 3, 4, 5, or 6. So in a dice roll, let's say x is our variable here, or it could be our set for a probability. We could say that our possible numbers are, so x exists, so x has a value that exists in the set, and we could have these numbers here, 1, 2, 3, 4, 5, or 6. Now this makes a lot more sense when we start looking at the idea of the previous one, when we say x could be any real value, or it could be any real positive value. And the one on the right hand side is, as you could imagine, with a line through it. That means that x does not, or in the x set, you do not have any negative real values. That's all really these two things mean. You'll see them come up a lot, especially when we start doing domain and range, which will come up in a further video and you're doing lessons, but that's what these two symbols mean. So it means that x in this case could be any real positive value, x could be any real negative value on the right hand side, or as I meant, real negative values are not in the x set. So in this case you could not have any values that are negative for what's expressed on the right hand side. That's all it means. Okay, like I said, this will come up later when you're doing domain and range, to be able to express your possible values you could actually use, and what we call piecewise functions as well. Alright, so fairly simple for our first two pieces of set notation. Now, these two here, I am going quite quickly because some of the set notations are fairly simple, and as you do more maths and we go through some more stuff, you're going to use them more and more. So this one here, you might have seen before. This is a symbol for union. Okay, it's going to make more sense in a moment. But the idea is, if I have two rules, what I could say is the fact that a union means it could be either or the rules. So let's say that my x values could be less than -2, or my x value could be more than 4. So another way you could see this is it's actually another symbol, if we're using English, is for or. Okay, like you would have done in probability, and you would have seen this before. So the idea being that if I did this here, and I'll have to use my set notation, which is something else, and that will come up later. Now all this means is x is in the set where x is greater than 4, or x is in the set which is x is less than -2. So the best way to sort of describe this, if I draw a number line, and we'll be doing a bit of number line work. If I say this is 0, 1, 2, 3, 4, 5, and -1, -2, -3, -4, -5. The easiest way to explain it is that in this set, x is anything less than -2. So it could be the value here for -2.1. But it also, because it's a union, it could also be anything greater than 4. So it could be here, so it could be 4.1 or greater. Okay, and we'll do a bit with this sort of notation, but we'll do this later on with when we're talking about those brackets we're talking about before, because we'll be looking more at number lines. So this is a U for union, or it also means U. Now another way to remember it, it's like a bucket. So any of these values, or any of these values, go in the bucket, which means it's a possible set of values you could use. On the right hand side, this one, a nice way to think about it, it looks like an N for AND, but this is known as an intersection. Okay, so an intersection of the rules on either side of it, whatever they are. So you might have seen again this in Venn diagrams. I'll show you an example on the next page. But the best way to think about it as an intersection, I like thinking of it like a horseshoe, because it pins the rules on either side of it so that it only exists in those. So if I was to draw a number line again, okay, and let's just do it like a sample space to make it easier. So if I have, again, we're just going to put some numbers down. So let's say we've got these numbers 1, 2, 3, 4, and we have a union of this data set with, sorry, this set of data. So then we'll have, let's say we've got 0, 3, 4, 7, and 9. Now, because we want to rule for what exists, it's an intersection between them, so horseshoe, which ones exist in both. So you'll notice that 3 exist in both, and 4 exist in both. What that means is this rule, with this in between, your only possible values for this set would be 3 or 4, because it's an intersection between the two things on either side. Okay, I'm going to ignore the number line I drew in for a moment, because we'll come back to that when we start doing some stuff with inequalities and so on and so forth. Okay, now remember you can pause at any time, but this one's going to be quite a swift video. So a nice way to look at it is actually when we're going to do Venn diagrams. So in probability. So if I've got A or a union B, what that means is it could be anything in A. Now I'm going to use two different colors here so it makes it easier. So bear with me so I can change the pen color. And let's go green. So, and B. So it could be anything in the A circle or in the B circle. Which means any of these values, because remember it's like a bucket. Okay, it's anything in the two rules existing. And just like before, on the right hand side, I might go to a black pen because it is nicer to see. We've got, if we put A and B, we want an intersection of those rules. So where does A and B both exist? In this case, it would only be the parts in between, because it's an intersection where both of the rules exist. Now it gets more complicated when we start using complements, which we'll do later in probability, but let's just leave it like that for the moment. Alright, now let's get to the meat of what I wanted to go through today, and that's these symbols here. But before we do that, I want to actually very quickly go over some stuff with inequalities. Now what you should have done before is where we look at values like where x is greater than 2 or x is greater than or equal to, let's say, 4, just to make it nice, easy, positive numbers. If I was to express that on a number line, let's just write some numbers in here. So we got 0, 1, 2, 3, 4, 5, 6, 7, 8, and so on and so forth. I'm not going to worry about the negatives because we're not going to do that today on this here, but it would be the other way around. Any value any value you can have for x would be greater than 2. The best way to draw this is on a number line. So what we do is we draw a hollow circle. I'll explain this in a reason in a second. And it's greater than, so it's to the right of it. So we put an arrow like this. Okay, so this means that your values for x, so in this set, is anything greater than 2. Now the reason it's hollow is it's like thinking about it, it doesn't exist on this line. It can't exist exactly at 2, it has to be bigger than that. Whereas the other one here, so let's just write that in, so we've got that x is greater than 2. You don't need to do this by the way, but it's a nice way for my video. Now on this one here, this is turning around and saying that x is greater than or equal to 2. Now some of you might have done this, or some of you might already figure out that if a hollow circle is going to be things that aren't there, because see how it's empty, this spot, if we want to include 4 in this case, first off we'll do it's greater than 4, but this is x is greater than 4. If we want it to include this value, we would shade it in. It's a full circle. Okay, so it would be a full circle because it includes this value. Okay, whereas a hollow circle does not include that value, which is why this would be x is greater than or equal to 4. Okay, so that's like a quick brief of inequalities and representing them on a number line. Now they have a very good use when you're doing things like quadratic inequalities, and some rules there, and we will get to that in this unit with functions. But before we do that, let me explain these brackets. Now it is really, really simple. Okay, so if I clear this off and I write in a number line again, let's just start here. Now the first thing we're going to do is these here are a way to express more defined sets without having to worry about inequality signs. So that's literally all it is. So our big bracket, like this one here, okay, that represents less than or equal to or greater than or equal to. That's not supposed to be that sign, greater than or equal to, but it doesn't matter because the key point here is this square bracket represents when it is equal to as well. Just like thinking about this is a big hollow circle, this one, when it's a curved bracket, that means it's just greater than or less than. Okay, it is as simple as that. So how do we express these on a number line? So first off, let's just find our numbers. So this one here, okay, let's change our colors. Let's make this one red. So this one here, okay, so this one here, first off, let's find our numbers. So it's at 3. You'll notice that's our lower value here, and our higher number is 6. Okay, so it can be anything in between those values. So we connect them like this to show that it could be anything between them. Now let's look at our signs. Notice that the 3 has a curved line on it, like this, like it was hollow. So therefore, this one has to be less than or a hollow circle. So this set, if we were expressing it, could be anything greater than 3, but this square bracket on the right means that actually it could also equal 6, which means we would have to fill in this circle here like so to represent it on a number line. to show that we could have anything. So we could have any values for this set here as 3.1, 3.0001, etc., all the way up to and including 6. That is it. And we're going to do exactly the same for the second one here. Okay, let's change our color. I like purple, so let's go for purple. So in this purple one, you're probably already getting it already. This one means that, first off, let's find our numbers. So we got -2 here. I'm going to put a hollow circle to start, up to 1. And we're going to connect them to show that it's between them. Okay, so this means in this case our -2 is also equal to that value, so you could fill it in, which means if you were looking for a set of values here, you wanted, or an answers, you could include -2 as your result, but you can't go all the way up to 1. Right? And with our inequalities we could write that like this. -2, so our x value, if we're saying this is a set of x inputs, so our x is greater than or equal to -2, but it's less than 1. Okay, very, very simple, but look how neat that is in comparison to using inequalities, and that's why we use it, because as mathematicians we like to be efficient, so we try to write as minimal as possible if we need to, because sometimes these get quite long. Alright, so let's just have a look. Now this one on the right is where we might get a little bit interesting. So that's what we're going to look at now. Now remember, this is a video, you can go back and re-watch these, and you will have some questions on a form. So now, as you probably should know already, this is your infinite sign, so this is negative infinity. Okay, and we're going to use the union here. Now there's a reason for it. You'll notice that there's no overlap between them, so there is no values that would have a intersection between my two different examples here. So we have a union of these two here. Now you could put a plus here, but we don't need to. Alright, so this is what we have. Now how will we express this on a number line? Well, first off, let's start with our number. So we've got -2. And as you're probably understanding, negative infinity is just to the left. Alright, now just check, do you need to make this hollow or solid? So have a look. Let's have a look here. Nope, it's a hollow circle, so that's perfect. And then we look at the other one. So -5. Oh, no, we could have had an intersection. I'll show you that in a second as well. So same thing, I'm going to put this one here. So it's -5. Now it goes from -5 up to infinity. Now let me just check. Now I know I haven't done this yet, but I always do my circles first. So first off, if you come back here, you'll notice that this has got our square bracket, so it needs to include this value. So therefore, your values could be anything here. Now this is a poor example. I'll draw another. We'll do another one in just a moment. So because this is all possible, so if I had this here, that actually means that x could be any real value, because that would exist. You got everything above that and everything below that. That would actually have to include all of them. Alright, because even 2 in this case, it would exist in this second group. Okay, this one here, because it's greater than -5. Okay, I did create this for an intersection, but I'll do that in a moment. Alright, so that's how you could express this set on a number line. Alright, now let me just rub this out. And we'll do it now instead, if we were to do it as an intersection. Now that's where it gets more interesting. So if instead we said this one here as an example, keep them the same, but instead it's an intersection of the two rules. Alright, that's a curved bracket, I'm sorry for my drawing. So again, we're going to do the same thing, exactly like we did before. We got from -2 to negative infinity, so it means it's going less than. And then we've got from -5 up to infinity. So we have, and remember, this is because it's got a square bracket, it's also filled in. Now here's where it gets interesting. Because it has to be a union, that means that actually I could change this to this rule. And you could write it like this here. So if we had these two rules as a intersection, I'm not sure if I just said union, I'm sorry. Okay, that means that it would be this one. How would you write this as the notation above? I'm just going to give you about 10 seconds, and then I'm going to do it. So can you write it first, or at least say it so that you've committed to it, and then do it? 5 more seconds. So another one on being able to do this is you could actually say, so it goes from, our lowest value here is -5, let's start here, and our highest value is -2. Again, I like starting with our numbers first, and then we include our sign. Okay, so it does not include -2, so you would actually say this one here, but it does include -5, so we'd use this bracket here. Very simply, you turned this one here into a much simpler form using our notation. That is it today. Okay, you'll have some practice with reading some number lines and putting it into notation, and taking notation and picking a right number line. I hope that was clear for you to understand. Make sure if there's anything that you need to ask, just ask me.